For 21 years, the United States military operated under a very comfortable, very dangerous illusion. We believed that as long as the F-22 Raptor owned the skies, American air superiority was a guaranteed fact of nature. We treated the Raptor like it was the end of aviation history. We looked at its thrust-vectoring nozzles, its radar cross-section the size of a steel marble, and its flawless kill ratios in mock combat, and we concluded that the game of aerial warfare had been permanently won. But war does not care about your legacy. War only cares about the math of tomorrow. And today, the math has changed. The Pentagon didn't just announce a new fighter jet this month. They announced the execution of an era. The F-22, the undisputed, undefeated apex predator of the skies, is officially being sent to the boneyard to make room for a machine that fundamentally breaks every known rule of aerial combat. Boeing has officially secured the next-generation air dominance contract, and they are currently cutting metal in St. Louis on the first physical airframe of the F-47 Phoenix. But to call the Phoenix a fighter jet is a catastrophic misunderstanding of what this machine actually is. It is not designed to turn with an enemy. It is not designed to dogfight. It is a flying, heavily armed supercomputer designed to ensure that a human pilot never has to look an adversary in the eye ever again. I am James. Welcome back to The Hidden Muster. Today, we are tearing the lid off the most classified black project in modern history. We are performing a forensic deep trace analysis of the F-47 Phoenix. We are going to look at the terrifying reality of the tailless stealth geometry, the thermal sorcery of its adaptive cycle engines, and why the United States Air Force is willing to bankrupt its own modernization programs to get this aircraft on the flight line by 2028. Sit down, lock in, and watch the telemetry. The sixth generation is here. To understand why the F-47 Phoenix exists, you first have to understand why the F-22 Raptor had to die. And to understand that, you have to look at a map. The Raptor was conceived in the late 1980s and early 1990s. It was designed for a very specific nightmare, taking off from Western Europe air bases, flying a few hundred miles into the Fulda Gap, and completely dismantling waves of Soviet fighter jets over a relatively confined geographical space. But the Soviet Union is gone, and the theater of war has shifted entirely to the Indo-Pacific. The Pacific Ocean is a tyranny of distance. The distances between friendly air bases and the potential flashpoints, like the Taiwan Strait or the South China Sea, are measured in thousands of miles, not hundreds. This exposes the Raptor's fatal, unfixable flaw. It has incredibly short legs. The F-22 has an unrefueled combat radius of roughly 460 nautical miles. In a Pacific conflict, that means the F-22 cannot even reach the fight without relying on a massive lumbering fleet of KC-135 or KC-46 aerial refueling tankers. The adversaries know this. Chinese military doctrine over the last decade hasn't focused on building a fighter that can beat the F-22 in a dogfight. Instead, they built ultra-long-range air-to-air missiles like the PL-15 and PL-21. Their strategy is brilliant and brutal. They don't need to shoot down the stealth fighter. They just need to shoot down the massive, non-stealthy tanker flying 100 miles behind it. If the tanker dies, the Raptor runs out of gas and falls into the ocean. Checkmate. This is the exact strategic crisis that birthed the next-generation air dominance. The Air Force issued a mandate: build an air superiority platform that possesses the extreme stealth of an F-22, but the fuel capacity and range of a medium bomber. Look at the blueprints of the F-47 Phoenix. It is massive. It is significantly larger and heavier than the Raptor, pushing into the size category of an F-111 aardwork. That sheer physical volume is entirely dedicated to internal fuel tanks and deep weapons bays. The telemetry indicates the F-47 boasts an unrefueled combat radius exceeding 1,000 nautical miles. This single metric changes the geopolitical map of the world. It means the Phoenix can launch from heavily defended bases deep within the second island chain, penetrate deep into highly contested anti-access area denial environments, loiter on station, engage multiple targets, and return home, all without ever needing a tanker. It strips away the enemy's primary strategy and forces them to fight the aircraft on its own terms. And on its own terms, the Phoenix is an absolute ghost.
When we talk about stealth, most people think about radar-absorbing paint. They think about the skin of the aircraft, but the skin is secondary. True stealth, what we call low observability, is dictated by the raw physical geometry of the airframe. For the last 40 years, from the F-117 to the F-35, stealth fighters have been optimized to defeat a very specific type of radar, high-frequency X-band fire control radar. These are the radars mounted on the noses of enemy fighter jets and the tracking systems of surface-to-air missile batteries. They are incredibly precise, capable of painting a target and guiding a missile to it. The F-22 and F-35 are practically invisible to X-band radar from the front. But radar technology has evolved. Adversaries like Russia and China have heavily invested in low-frequency radars, VHF and UHF bands. These early warning radars operate on wavelengths that are meters long. The problem with current fifth-generation fighters is that their physical features, specifically the vertical tail fins, are roughly the same size as these long radar waves. When a VHF wave hits the vertical stabilizer of an F-35, it resonates. It creates a return. These low-frequency radars aren't precise enough to guide a missile, but they are precise enough to tell an enemy air defense commander, there is a stealth fighter in this general 10-mile sector. Send interceptors. The F-47 Phoenix eliminates this vulnerability entirely through what we call all-aspect broadband stealth. Look at the airframe. There are no vertical tail fins. There are no rudders. It is a completely flat flying wing design. By deleting the vertical stabilizers, Boeing has engineered an airframe that does not resonate with low-frequency radar. It is invisible from the front, invisible from the side, invisible from the rear, and invisible across the entire electromagnetic spectrum. X-band, S-band, VHF, UHF, it doesn't matter. The Phoenix is a thermodynamic hole in the sky. But this raises a massive aerodynamic paradox. If you remove the vertical tails, the very control surfaces that provide yaw stability and allow an aircraft to turn, how do you maneuver a supersonic fighter jet? The answer lies in fluidic flight controls and next-generation thrust vectoring. The F-47 does not rely entirely on moving mechanical flaps to alter its trajectory. It bleeds high-pressure air directly from its own engines and vents it over precisely calculated points on the wing surface. It literally uses air to push air. Combined with highly advanced 3D thrust vectoring nozzles hidden deep within the stealthy serpentine exhaust ducts, the F-47 can pitch, roll, and yaw at Mach 2 with a level of agility that defies its massive size. It is a machine that maneuvers using the sheer brute force of fluidic flight controls. You cannot build a sixth-generation fighter with a fifth-generation engine. The beating heart of the F-47 Phoenix is the result of the Adaptive Engine Transition Program, or AETP.
Since the dawn of the jet age, engine designers have been trapped by a fundamental compromise. You can build a turbojet engine, like those on the SR-31 Blackbird or the Concorde, that pushes a small amount of air at extremely high velocities. This gives you blistering supersonic speed, but it drinks fuel at a catastrophic rate. Or you can build a high-bypass turbofan engine, like those on a Boeing 777 passenger jet, that moves a massive volume of air at slower speeds. This gives you incredible fuel efficiency and range, but terrible combat acceleration. Fighter jets have always had to find a middle ground, until now. The AETP engines inside the F-47 Phoenix do not compromise. They are essentially two entirely different engines housed inside a single casing, capable of physically reconfiguring their internal architecture in mid-flight. They utilize a third stream of airflow. When the Phoenix is launching from a base in Guam and needs to cruise across 1,000 miles of open ocean, the engine opens up the third stream, operating like a highly efficient commercial airliner. It sips fuel. But the exact microsecond the onboard sensors detect hostile airspace, the engine computer seamlessly shifts the internal geometry. It closes the third stream, dumping all that air directly into the combustion core. Instantly, the engine transforms into a high-performance brute force turbojet, capable of pushing the massive airframe well past Mach 2 in sustained supercruise without the use of fuel-guzzling afterburners. But the speed and range are only half the story. In modern aerial combat, the biggest threat to a stealth fighter isn't just radar, it's heat. Infrared search and track sensors can detect the friction of a jet pushing through the air and the massive heat plume of its exhaust from 50 miles away. Furthermore, the F-47 is packed with high-powered radar arrays, electronic warfare suites, and massive supercomputers. All of these electronics generate an insane amount of internal heat. If you don't cool them down, they melt. The AETP engine solves this by acting as a colossal thermal management system. That third stream of bypass air isn't just for fuel efficiency. It acts as an insulating blanket of cold air that wraps entirely around the hot core of the engine, suffocating the thermal signature before it ever leaves the exhaust nozzle. The Phoenix actively manages its own thermodynamics. It uses its own unburned jet fuel as a liquid coolant, running it past the hot avionics to absorb the heat before pumping it into the engine to be burned. To an enemy infrared camera, the F-47 doesn't register as a burning jet engine. It registers as a patch of cold ambient atmosphere. It is thermally invisible.
If you evaluate the F-47 solely by the missiles it carries in its own bays, you are failing to grasp the true horror of its design. The U.S. Air Force does not classify the NGAD platform as a solitary fighter jet. They classify it as a system of systems. The human pilot sitting inside the cockpit of the F-47 is no longer a stick and rudder aviator in the traditional sense. They are not looking out the canopy scanning for enemy contrails. They are a macro-level battlefield commander. They are the quarterback, and their offensive line is composed of a swarm of autonomous, artificially intelligent robotic wingmen. Under the NGAD doctrine, the F-47 never flies into combat alone. It acts as the command hub of a localized swarm of collaborative combat aircraft, or CCAs. These are uncrewed, highly stealthy drones that cost roughly $15 to $20 million each, a fraction of the cost of a manned fighter. Imagine a combat scenario over the Taiwan Strait. The human-piloted F-47 sits completely silent, with its active radars turned off to remain entirely undetectable. It loiters 150 miles behind the front lines. Meanwhile, the pilot commands 4 CCA drones to push aggressively into the contested airspace.
These drones act as the eyes, ears, and kinetic shields of the Phoenix. Two of the drones might act as sensor nodes. They push forward and activate their powerful active radars, deliberately lighting themselves up like Christmas trees on enemy screens. When the enemy air defense batteries power up to shoot at the drones, they instantly reveal their own hidden locations. The drones instantly data link those exact coordinates back to the silent, waiting F-47. The human pilot sitting 100 miles away reviews the tactical overlay generated by the onboard supercomputer. With a single press of a button, the pilot commands the other two heavily armed drones to ripple fire a volley of IM-260 Joint Advanced Tactical Missiles directly down the throat of the enemy radar sites. If the enemy manages to launch a counterattack, they are firing at the $15 million drones. They are fighting the puppets. The puppet master, the F-47 Phoenix, remains completely dark, completely untouched, orchestrating the systematic dismantling of an enemy nation's air defense grid without ever crossing the threshold of danger. The concept of a fair fight has been entirely erased from the American military vocabulary. This level of complex coordination requires a processing capability that human biology simply cannot handle. A human brain cannot process the raw data feeds from half a dozen satellites, a naval destroyer group, AWACS radar planes, and a swarm of AI drones simultaneously, while also flying a jet at Mach 2. This is why the F-47 is equipped with a heavily classified cognitive electronic warfare suite, powered by localized machine learning. The aircraft possesses a digital co-pilot. In legacy fighters, electronic warfare was a game of pre-programmed libraries. If an enemy fired a specific type of radar at an F-15, the F-15's computer would check its database, recognize the frequency, and emit a pre-programmed jamming signal. But what happens when the enemy uses a completely new, highly advanced radar frequency that isn't in the database? The legacy fighter gets shot down. The Phoenix does not rely on static databases. Its cognitive EW suite listens to the raw electromagnetic spectrum in real time. If it detects a completely unknown, highly advanced, hostile radar signal, the onboard artificial intelligence analyzes the waveform, immediately writes a custom, highly specific jamming algorithm from scratch, and blasts it back at the enemy. It does this in milliseconds. It learns, adapts, and neutralizes unknown threats autonomously. The human pilot doesn't even know it happened. The pilot simply looks at the panoramic glass display, and the computer highlights a sector of airspace and says, "Threat neutralized. Proceed to target." The interface is designed to reduce pilot workload to absolute zero. The machine handles the physics, the avionics, and the electronic survival. The human is there solely to handle the morality of the kill chain, to make the final, lethal decision of pulling the trigger.
So, what is the current telemetry telling us? Why is the veil of secrecy finally lifting in April 2026? The intelligence is clear. The United States is accelerating the timeline. The Indo-Pacific pressure cooker has forced the Pentagon's hand. In the early months of this year, the Air Force successfully finalized a sweeping reallocation of funds, pulling billions of dollars out of legacy modernization programs to hyper-accelerate the NGAD production lines. Boeing has completely revolutionized their manufacturing process. They're utilizing full-scale digital engineering. The F-47 was completely designed, tested, and flown in a high-fidelity virtual environment millions of times before a single piece of carbon fiber was ever cut. By the time the first physical prototype rolls out of the hangar doors for its maiden flight, the software running its brain will already be a combat-hardened veteran of a billion virtual wars.
This is why the F-22 had to die. Maintaining a fleet of 1990s-era stealth fighters is a logistical nightmare that drains billions of dollars a year. The Air Force looked at the ledger, looked at the rising threat of fifth-generation adversaries, and made the brutal, necessary choice to amputate the past to secure the future. The F-47 Phoenix is not an airplane. It is an extinction-level event for the concept of traditional air combat. There will be no more cinematic dogfights. There will be no more heroic merges at 20,000 feet. The era of pulling 9 Gs to get a missile lock on an enemy tailpipe is dead and buried. The next war in the sky will be fought over hundreds of miles of empty ocean, waged by silent, invisible supercomputers, orchestrating swarms of robotic proxies. It will be cold, mathematically perfect, and utterly devoid of mercy. The Phoenix is rising, and it is bringing the absolute darkness with it. I am James. This has been a deep trace analysis for the hidden muster. Keep your eyes on the skies, but remember, the things that will actually decide the fate of nations are the things you will never ever see coming. Watch the telemetry. Stay in the shadows. We are out.